Some of you may have seen postings I put up about something called the ontology gap. The basic problem is in RDF you have schema, and in property graphs you don't. That's an oversimplification, but there are very few minutes available. And we want to incorporate some existing work on schema, LEX, LDBC, extended GQL schema, plus OpenGQL, stuff to do with GQL implementation, e.g. Antler grammar, and Antler grammar that might get extended because we want to extend the GQL schema definitions into this work on text-to-graph query, because basically you can't do text to something without a schema when you're looking at databases. And all of the SQL predecessors of text-to-graph query implicitly, but very heavily rely on, or explicitly actually in many senses, on the existence of schema. So we have extended a lot of pre-existing work in this area, which is sort of pitched or poised, I think, to be able to contribute to the this new project, the text-to-graph query project, and it's a very strong sort of use case for what's needed, why schema is needed. So I'm not going to spend lots of time on this, but here's a very recent article on LinkedIn from Atanas from GraphWise, used to be Ontotext, a founding member of LDBC, still active member of LDBC. The lack of proper schema language in LPG is a major limitation for graph RAG. True. If you look at Spider, which is one of the text to SQL environments, you'll see that schema plays a prominent role at every point in the process. And even if you look at things like Bird, where people are trying to actually evade the problem of schema and look at data and so forth, what they're actually doing is schema inferencing, in effect, in a kind of a way. So basically, I think the need for property graph schema is obvious. There are many, many motivations for this. And what we have at the moment is a big advance that happened with GQL. We created a thing called a graph type in GQL, which is a very simple structural statement about node types and edge types and how they come together to define the structure of a graph. And there's a way of actually formalizing the use of labels to identify those node types and edge types. But what we lack is constraints. And there are many, many kinds of constraints that people are used to when they're actually working with data. I'll come back to the specifics of that, but another way of looking at all of this is that SQL and PGQ can do something that Cypher can't. That's introducing this idea of schema. But SQL can do things that GQL can't do, like keys or domains or check constraints or foreign keys for referential integrity or information schema to be able to actually look at the schema that you've got, or type DML, because implicitly every DML operation in SQL is typed. It's about a particular row type that you're actually operating with. JSON schema has things that you can't do in GQL, and some of those things you can do in SQL. So there's effectively intra-record constraints, cross-field validations, ranges, string formats, ... And they're all roughly equivalent to what you can do in shackle core constraints, actually quite closely equivalent. And they're also equivalent to some of the things you can do in GraphQL schema. So familiar stuff, but it hasn't been brought together. And then in the RDF world, we've got RDFS and Shackle, and there's also been some academic work, PG Schema, that a number of us have been involved in, which thinks about problems like subclassing and subgraph shapes. And then there's something that's very familiar, widely out there, which is entity relationship modeling in whatever guise it takes, which includes UML. And there are things like cardinality constraints on elements and relations. And there's the problem of the gap between the property graph data model and the EER model, if you like, or meta model, which is one key central gap is n-ary relations. And there is also this issue of subtyping. So one way of summarizing what we're trying to do with LEX is get what you can already get in other domains relating to data management. In other words, this isn't necessarily super innovative, but bringing it together is about leveling the playing field. So Max talked about all this SQL stuff that's out there, but some of that's because The SQL world is just plain more mature and has got more things going for it. So I think that, G.V, your whole kind of starting point, in a sense, Arthur, from my understanding, was why can't we have the same kind of tooling, right, and the same kind of workbench that everybody can walk up to? There are 50 of them in the SQL world, right? And I think that was a very potent, correct perception. And we have a similar kind of problem here on the schema front. Some of the prior work, there's a straw man that was done earlier on this year, which actually says, well, what could this all look like if we extended DDL? What are the things we'd address and how would they look? And by the way, why can't we have a YAML representation of a schema that's more easily processable in some context? And so this kind of reflects this idea that schema equals type and constraints. At the moment, you can create a graph type. We'd like to be able to create a graph schema that includes a graph type, but lets you add those constraints on top. And so a LEX schema would be a GQL graph type plus some of the constraints that are available in other environments and anything else that we have to specially invent. And there is one particular area that we do, I think, have to innovate in, and that's the area of referential integrity and what that means in a world where you've got hard edges and not just the sort of value referential integrity that exists in SQL. So it's an evolution of GQL graph types. But at the same time, we want to recognize that there are other things in the world. So one of the very first things we'd like to do is be able to say, this is a definition, including keys, that is exactly parallel to a definition I can make in SQL PGQ. SQL PGQ's got basically its graph view definition has two parts to it. One is let's define a graph data model. The other part is how does that map to SQL? You can hide all the mapping to SQL in SQL views, and then you can disappear that part and then say SQL PGQ is about how you define a graph schema. We want to have a graph type in GQL. How do we define a graph schema? We want to bring them together, make them interoperable, make sure they can have the same level of facilities and so forth. Because part of all of this is driving the agenda of the parallel lines that eventually converge between GQL and SQL PGQ. They're very closely related standards. That's a good thing and something we want to actually continue to promote. How much time have I got? It is. And it says, am I going to 20? Is that the end of the? Yeah. Okay. So one thing that's we've been working towards, and it's now beginning to emerge, and I think this is actually, a public link, and we'll bring it over onto LEX, onto an LDBC or a GDC repo, is an actual library, which is called Grash Lex, for to actually build a GQL catalog and an LEX schema, so that you can actually do that for real, and you can see what that would look like, and you can look at how we'd store information about a graph, how you would validate graph information, and so on and so forth. And this involves all kinds of issues like data type mappings between the different environments and so forth. So it actually is designed to be something that could be a concrete contribution to what we're doing in text to graph. And also more generally, a way of experimenting with the and propagating the ideas about the actual content of LEX. Now, you could imagine LEX would become JEX because we're now called Graph Data Council, but that's not really very important. We were originally intending to try and get something out in 2025. I had a stroke at the beginning of this year, or early part of this year. Things haven't happened in between times. My recovery is going well, but we're sort of restarting. And what we're looking at here is our baseline is the catalog, the graph types, the element type identifiers that exist in GQL, things that didn't exist in Cypher. We want to, in the very first instance, and we were having some discussion about this last night, add in the kind of keys that you have in SQL, and also the idea of an information schema graph. So SQL has effectively a system table, set of system tables, which are views, which are represented as information schema. We need the same thing, and that relates to a very potent concept, which is that a schema can be represented as a graph. So if you take a graph type, you can think of every node type as a node and every edge type as an edge, and then that generates, a graph representation of a schema. You then need to map that over to what's going on in terms of the definition of the content types. And so it's very intuitive notion that you use a graph as a schema, and then you can visualize that graph, which is a useful kind of thing. But it also has to be tied into an understanding of the representation of data, the way the records that are associated with elements in a property graph. Because one way of thinking about a property graph is it is a collection of trees of nested record data, and then they're associated within the graph topology. So the trees need to be controlled. We need to control what they look like, and many of the constraints are actually about the content of those records, those nested records. And then we have other kinds of constraints which are more structural, and that matches, or topological, that matches the nature of the property graph data model. So another thing that I mentioned cardinalities, and that's kind of like an onflow from keys in some ways. JSON and JSON schema are tools that are very widely used, and are focused on the nested data problem. And so one of the concepts here is, should we reproduce yet again another way of actually describing nested data and constraints on nested data, or should we incorporate work that's already been done? You could do both, but there's a definite interest here in actually looking at what we could do to leverage JSON schemas. So that if I have JSON described data, I can incorporate it very easily into this world, but I can also incorporate it into the schema. And this is something that Oracle have already done in their product, where Oracle used JSON schema to actually describe the nested structured data that they can then actually incorporate into an SQL PGQ query, and they can query down into the nested data and so on and so forth. Subtyping or subclassing. Subclassing is an important component of what can be done in the IDF world. It's important more generally, because if I can make statements at a supertype level, like this is a constraint that applies to all persons, irrespective of whether they're employees or managers or whatever else it might be, I can make one statement instead of many statements. And it's very easy for me to control and understand that to update that to correctly look after such a schema. If I've got that capability, if I have to do everything the way that graph types makes me do it, I have to talk about every single possible permutation in terms of edge types, for example. You know, this could go to that could go to the other, or whatever it might be. So subtyping is also something that's very natural, because GQL and SQL PGQ and Cypher, in effect, have got this kind of structural typing notion. So basically, what is it that distinguishes this set of nodes from that set of nodes, or this set of edge types and that set of edge types? And the answer is the nature of the content, the data content, the actual record type. So if I have record types and I look at them and analyze what's available at a schema level or an inferred schema, if I'm just looking at data, those record types will sort into a natural lattice, a type lattice. And that happens whether you like it or not. But GQL graph types doesn't recognize it, and it doesn't make it easy to do any of the operations like defining those kinds of relationships. So I can't say something which is very familiar for most programming languages, which is I want to extend this type in order to make it into that type. Even though that is possible to represent in GQL graph types, you can't see it, doesn't stand out, and it's hard to do. So there's a lot that can be done there to make things better from an ergonomic perspective. And then we move into the last point, which is more sort of hasty, speculative, complicated. There's the whole issue of foreign keys. And foreign keys, there's value-based foreign keys like in SQL, but then we've got this structural issue of edge types, and edge types that have to exist in conjunction with other edge types. So it effectively are like subgraph types. And those subgraph types are like the referential integrity graph in SQL, but making it visible, which it isn't. And nobody ever, occasionally a vendor will produce a tool that will show you the rig, but it's not something that people actually talk about that much. And then if you look at some of the things that happen in Shackle, they're sort of based around subgraph types in effect, because shapes are like subgraphs, and they use Sparkle to sort of pull out subgraphs, and all of those kinds of ideas could apply. How far do you want to go? I mean, I think that if you look at the new work that's going on in Shackle 2.1, it's actually going a very long way, and I'm not sure how far it's there on the sort of diminishing return spectrum, but this issue definitely exists. And then there's another interesting issue, which is entering relations. There are other things like hyperedges and so forth, where there's two possible approaches, one of which is to actually modify the data model, which is a very difficult thing to do, because it's standardized and it's lots of things based on it and so forth. And the other is whether we can simulate some of the things that aren't present in the data model by creating schema constructs that mean that there are standardized mappings down from this sort of more elevated data model to the more basic data model. So that brings me to the point where I've got about 25 other slides, but I've basically said what I think needs to be said. And I'll just finish on this, that we see the beginning of the sort of, reiteration of the Lex work with some very interesting stuff that Stefan started working on in his Microsoft incarnation, where he's addressing this very first issue that I was talking about, which is keys. And that's something that has been cross-posted between the formal standards process and what we're doing in Lex. And I think that, we're hoping to talk at WG3 at the end of this month in Barcelona about what we're up to and how that could play into the official standards process. There's so much to say about this. I'm sorry for rushing it in this way, but I think that getting this right is really, really critical for the future of graph data.